All right. So for Lagrange multipliers, the same process follows, but just one difference is you have an extra term which would be a constraint term in your question, right? So I thought, based on a lot of doubts asked recently by a lot of my students, I think the doubt was in this question. It appeared in one of the mock exam. I think it was 2014 mock exam. And a lot of the students had doubts in this question. So I thought, hey, what's better than just using this question to demonstrate constraint optimization, how it works. So in this question, again, like please take some time to go through the question really carefully. What we have is we have a utility function where two quantities, small x and small y, are given for two goods, capital X and Y, right? And the price is given for each. Okay. And then there is a budget provided, that the consumer has a budget of $M. All right. Use Lagrange multiplier method to determine the quantities X star and Y star that should maximize his utility, subject to this budget constraint. All right, fair enough. So clearly, um, to optimize my utility, this becomes my objective function, because that is something which we need to optimize, right? And subject to the budget constraint, right? So what is the budget constraint? I have a budget of $M, but what is the total amount of spending I can do? I can spend a total of, let's say, X quantities I can consume, and each quantity of X cost me P dollars. For Y, I can consume a total of Y quantities, and each quantity of Y costs Q dollars, right? So that would be my total spending. However, I'm given that there is a budget constraint. So my maximum budget would be capital M. So at an optimal condition, if I want to, ensure that all of M is used up in spending towards X and Y, then my total spending would be actually exactly equal to M. That would be optimal condition. I shouldn't be left with any money, right? So Px plus Qy equal to M is my g of x comma y. And this u of x comma y is my objective function, and we call that as f of x comma y. So that's fine. And in that case, the Lagrangian, so make sure you use this particular symbol, no other symbol like capital F or any other function, no. Just use this capital L for a Lagrangian, and in bracket it would be a function of x comma y comma lambda, right? So the Lagrangian is equal to f of x comma y, or feel free to just use u of x comma y instead of f, that's fine, minus lambda times g of x comma y. And this is not equal to anything. This is not equal to 0 or anything, right? So don't put equal to 0 yet. Okay, so just substitute fxy and gxy. So we have then x plus 1 whole cube plus y cube, and the entire thing 1 by 3. This is my fxy, minus lambda times the utility, which is px plus qy minus m, right? This is my Lagrangian. Now for critical points, the derivatives, the first order derivatives, which is Lx, would be equal to Ly, would be equal to L lambda, would be equal to 0. This is something I know, right? So let's call that equation 1. Right. Now let's find actually what would be this Lx, Ly, and L lambda. So Lx is, so if I want to differentiate this, clearly I would need chain rule. So the outer function first gets differentiated. So I'll have 1 by 3 times the outer, whatever the outer function is, uh, and this will be 1 by 3 minus 1. So I'm using x to the power n differentiation formula, right? So now that the outer function is differentiated, I multiply that with the differentiation of the inner function. The inner function will be with respect to x. I'm not concerned with y because that's a constant, that will be 0. So x will then become 3 times x plus 1 whole square, right? So that's the inner function done. So the outer function is differentiated, then multiply with the inner function. So that's done. And minus then lambda times px. So derivative of px with respect to x will be just p. So it will be minus lambda times p equal to 0, right? Using 1. So I'm just using 1 to say why it's equal to 0, right? We can obviously simplify this further. Remember in class I told you that it's always best to use this relation and right over there write down what is lambda. Lambda would then be equal to 1 by, if I divide, first I take minus lambda p on the right hand side and I divide both the sides of the equation by p, then it should be 1 by 3p times x plus 1 to power 3 plus y cube, and 1 by 3 minus 1 will be minus 2 by 3, right? And then this will stay 3 times x plus 1 whole square. So it will stay like that. Okay, so that is lambda. This is, let's call this 2. Okay, now what is Ly? We do the same thing again. We differentiate the outer function first. So it will be 1 by 3 times basically what we did with x. It will be the same again, y cube, the whole thing to the power 1 by 3 minus 1. Alright, I should have written this a bit more down so that there is a bit of space. Multiply this with the inner function. The inner function would be, in this time it will be 3y square, 3y square, because x plus 1 would be 0, right? So the outer and inner function is done. So now we have minus lambda times px would now be 0, qy will give me just q. So it will be minus lambda times q, and that is equal to 0 using 1. Right, again, we use this equation to find what is lambda again. So if I take minus lambda q on the right hand side and divide both the sides by q, then that should give me lambda is equal to 1 by 3q times x plus 1 cube plus y cube times 3y square. Alright, so that is my lambda, right? Okay, I don't know why this thing came up. Right, so L lambda would then be, if I look at the Lagrangian function over here, right? So sorry about all the noise in the background. People outside selling vegetables. I cannot help it. So, holy shit, the entire family is out there selling vegetables, right? So minus lambda times this, if I differentiate with respect to lambda, it will be, where did the marker go? Just a second. Okay, it's back, right? So this will be minus of px plus qy minus m, and that will be equal to 0 using 1. Alright, now we have found the three partial derivatives. Using 2 and 3, we can compare the lambdas. So using 2 and 3, we can say that 1 by 3p times x plus 1 cube plus y cube to the power minus 2 by 3 times 3x plus 1 whole square would be equal to 1 by 3 cube this time, x plus 1 whole cube plus y cube to the power minus 2 by 3 times 3y square, right? So we can see that clearly some terms will cancel out. So I have this term cancelling this term out. I have 3 and 3 cancelling each other out. So what I have left eventually is x plus 1 whole square by p is equal to y square by q, right? And this means that x plus 1 by y whole square is equal to p by q, which means that my y would be equal to under root of q by p of x plus 1, isn't it? So if I take if I take square root on both sides plus first, and if I bring y on the right hand side and this p by q on the other side, it will just become a reciprocal. So it becomes q by p by q becomes q by p, right? Okay. So now that we know this relation, let's call this relation, uh, let's call this guy over here relation 4, and this is 5. So from 4 and 5, what do we get? From 4 we have, from 4 we have px plus qy equal to m, right? Now if I substitute y using 5, then I have px plus q times root q by p times x plus 1, right? So I just substituted y and that is equal to m, and I can say that I have used equation 5 for this, which is this one, right? Okay, so now I can open the brackets. So I have, this implies px plus q root q by p times x plus q root q by p is equal to m, right? So if I multiply both sides by, oh, actually this root would be for both. This root is for both q and p. So if I multiply both sides by root p, then what do I get? I have then p root p times x, and if I multiply root p, then this denominator root p would go away. So this would be plus q root q x plus q root q would be equal to m root p. Okay, so now if I take x common, then what do I get? I have p root p plus q root q, and that will be equal to m root p, and I'm taking this q root q on the right hand side, that will be minus then q root q. This means that my x will be equal to m root p minus q root q upon p root p plus q root q, right? So it's a bit of a hustle, this question, but we eventually get x. Now we use equation 5. We know what y is in terms of x to find what is y in terms of m, p, and q. So y is equal to under root q by p of x plus 1, right? So what is x plus 1? If my x is this, then this means that x plus 1 would be basically m root p minus q root q upon p root p plus q root q plus 1. And if I take a denominator of p root p plus q root q, then my numerator becomes m root p minus q root q plus the same as the denominator, so that would be p root p plus q root q. And you can see that q root q terms would get cancelled out. So I then have m root p plus p root p upon p root p plus q root q. Right? So that is my x plus 1. X plus 1 is this. Let's call it equation 6. Right? So I just have to multiply root q by root p to my equation 6. What would that give me? So let's say I have, if I take root p common from equation 6, I'll then have m plus p upon p root p plus q root q. And I multiply this by root q by root p. So my root p will cancel out. So I'll have root q times m plus p upon p root p plus q root q. So now I get my y and x. Okay, that is my x and that is my y. Okay, and this value of x and y, because they are coming from the Lagrange multiplier, they are my optimal values. Remember, like in the case of Lagrange multiplier, you don't have to prove that these are the optimal values. That's one respite, thank goodness, because it's already such a hustle, right? So what do we have to do? So let's have a look. The question asked us to find x star and y star. Now that is something we have found, right? And the next thing we need to do is suppose that for any given values PQM, the consumer's maximum utility has a budget constraint this. So we have to now find V, capital V, okay? Now what is capital V? Capital V, if you remember, is basically we have to substitute x star and y star in this utility function, right? So let's write them down, right? So I have u of x comma y was x plus 1 whole cube plus y cube, and the entire thing had to the power 1 by 3, right? V is basically substituting x by x star and y by y star in the utility function. That would be my V. So what is x star? Actually, we already have x plus 1. So let's just use this. So x plus 1 is, if I take root p common, then I have m plus p upon p root p plus q root q, and the whole thing cubed. This is my x plus 1 square. Now x plus 1 cube, sorry. Y we already know is plus root q times m plus p upon p root p plus q root q, right? This entire thing whole cube is my y cube. And then this, oh dear, this entire thing again to the power 1 by 3 is basically my v. Okay, now let's simplify this further. This root p cube, we can write that separately, root p cube times m plus p whole cube And again, this p root p, we can write that as root p whole cube. And this q root q, we can write that as root q whole cube. The motivation behind changing p root p to root p whole cube is basically we see that we have a root p and we are doing a cube of that, plus we have a root q and we are doing a cube of that. Because the denominator is the same, I can then have m plus p as a common term, and I then will have root p cube plus root q cube. So given that my denominator is also root p cube plus root q cube, I have some chance of cancelling some one or two terms out, right? Let's have a look. Again, with root q, and I'm doing a cube of that, so it will be root q cube times m plus p cube upon p root p is root p whole cube plus root q whole cube, and the entire thing to the power 1 by 3. Now clearly the denominator is the same, so I have root p cube plus root q cube, okay? And in the numerator I can take m plus p cube as common, so I have m plus p whole cube, right? And then I have in the denominator I have a cube of that, right? Because the entire thing is cubed for both, right? And then I'll be left with root p cube plus root q cube. Clearly, this root p cube plus root q cube would cancel this 3 out and it will become 2. So eventually I have m plus p whole cube upon root p cube plus root q cube to the power 2. This is my v, okay? One last thing I need to do. This entire thing had a power 1 by 3, so that would remain. So clearly I can have another step. I have m plus p cube would go away, and the denominator would be root p cube plus root q cube, and the entire thing will have a power 2 by 3 now. So I'm individually allocating this power to the numerator and to the denominator, right? So that is my v. So what is del v by del m then? Del v by del m would be equal to, so this denominator is a constant, so I can take that separately, right, to the power 2 by 3. So this entire thing is a constant. So derivative of m plus p with respect to m will be 1. And that's it. So this is my del v by del m. And this thing I told you about Lagrange multiplier is that we can always prove that del v by del m is equal to lambda star. This thing is equal to lambda star. Could have made a better lambda, right? And the same thing we have to do in this question also. So if you go back to the question, we have found x star, we have found y star, we have found what is v, right? And we have found it in as simple as possible expression, right? Now we have to use our values of x star and y star to determine that what is lambda star. So in the previous, just before now, we found v. So now we have to find what is lambda star, and eventually we'll find that they are equal, right? So to find lambda star, we can use either equation 2 or equation 3. Either is fine, right? So let's just use equation 3 itself. So I have 1 by 3q. Let's see how my memory is. So 1 by 3q times x plus 1 whole cube plus y cube. And the entire thing will have 3y square, and that will be lambda, right? So just verify if my memory is okay or not. So 1 by 3 cube, yeah, that looks good. Okay, so if my lambda is this, if lambda is this, using, I believe that was equation 3, but do verify that in your time, using 3. So therefore, lambda star will just be, if I replace x and y by x star and y star, then that should give me my lambda star. Okay. Now x plus 1, x star plus 1 I already have. So I'll directly use that result. Let's have a look. It was root p common bracket m plus p, right? So root p common bracket m plus p upon p root p, I'm writing that as root p cube, plus q root q, I'm writing as root q cube, right? And the entire thing is cubed. That is my x star plus 1. And y I believe was root q. Root q times m plus p upon root p cube plus root q cube. And the entire thing is, okay, and we multiply that by 3 y star square. So y star again would be root q m plus p upon root p cube plus root q cube. Okay, so that 3 and that 3 over there should cancel out. So what will I get? I'll have root p cube plus root q cube, and then I'll have m plus p whole cube, right? And the denominator would be root p cube plus root q cube, and the entire thing to the power 3. And this term will cancel this 3 out to 2, and to this I will have root q m plus p upon root p cube plus root q cube. Alright, let's have a look. Is that, yeah, that is my lambda star. Okay, so if you go ahead and solve this further, then oh, there's something missing. This entire thing will have a square attached to it. This bit would have a square attached to it, right? Okay. Alright, another thing we had missing was that this term had minus 2 by 3 attached to it. So there's something we missed out throughout. Minus 2 by 3, minus 2 by 3. Okay, right. So then this will be m plus p cube times minus 2 by 3, right? That will cancel out, upon root p cube plus root q cube to the power 2 into minus 2 by 3, right? And to this we will have so root q square will become q times m plus p whole square upon root p cube plus root q cube, and the entire thing's square. And if you remember, I had a 1 by q left over as well. That 1 by q would be there outside, and that will cancel this q term out, right? So then what do I have? I have m plus p to the power minus 2 times m plus p to the power 2 upon root p cube plus root q cube to the power, here is minus 4 by 3 and here is 2. So it will be minus 4 by 3 plus 2. These terms would cancel out, and I have what? 1 upon root p cube plus root q cube, and the entire thing have power of 3 minus 4 plus 6, so that is 2 by 3, and that is the same as del v by del m. So hence proved that lambda star is equal to del v by del m. And that's a massive question. I took almost half an hour to solve it, but my explanation would be that I'm using a graphics pad to write down my answer, so I'm not as quick as I would have been on using pen and paper, and I had to explain you between all the different steps. So that's why the half an hour. But if you go ahead with this question using pen and paper, using the understanding and the flow after lots of practice of how to proceed with these kind of questions, I think about 15, well, 15 might be too harsh, 20 minutes I would say, or somewhere between 15 to 20 minutes should be justifiable amount of time to solve this kind of question. All right. So again, I do acknowledge it's a very difficult question, but hey, we need to be prepared for the worst case scenario. So I just showed you that it can be proven, and just a bit of tweaks and rearrangements in the terms and simplifying things to the last step can really go a great way towards helping us to solve these kind of questions. So again, all the very best for constraint optimization questions. And if you have any specific doubts, do reach out to me. All right, take care. Bye bye.